by BITSGOA Women in Tech. We are a community of BITSGOA's women in technology where we collaborate, discuss ideas, and share opportunities. We comprise essentially an all-women team who are a part of our college, juniors, seniors, alumni, and there are 4 of us who are coordinating the activities. We aim to provide guidance for networking, discovering the right opportunities, and most importantly, finding a safe space for conversation and mentorship. Our mission is to nurture a platform where all women and other minority genders can encourage and learn from each other. Coming back to summer internships, as is popularly known, SIPs, these are a great way to exhibit your potential as a student to companies and to explore various fields and career choices that you see are fit for you. And you can even get the very prestigious PPOs from these SIPs. So for those planning to pursue a career in IT, electronics, or non-core roles, that's who these sessions are aimed for, especially since the SIP season is coming up this August, and it'll even start in late July. So these talks will help you help provide clarity regarding the application processes, timelines, requirements, and give perspective regarding various fields and how to choose your interest and approach preparation, general tips, and so on. So today's talk is focus on electronics roles. So we'll be having an AMA session. You guys are encouraged to ask doubts about the interview process, about problem statements, how to approach problems, how to think during an interview, what kind of answers are expected of you, and of course, just how to prepare in general. So today we have 3 speakers with us. Stuti Shah is an electrical and electronics student going into her 4th year. She has joined Texas Instruments as a digital design intern this summer. Mansi Doshi is a 4th year electronics and instrumentation student pursuing a minor in data science, and she's joined Nvidia this summer as a hardware intern. Ashlesha Jagdale is a hardware intern at Nvidia. She is currently pursuing electronics and communications and has completed her 3rd year, so she's also going into her final year. So thanks for making it, Stuti, Mansi, and Ashlesha. Over to you now.
Yeah, okay, I'll present just later on. Can anyone confirm if my screen is visible or not?
Yes, Mansi, it's visible.
Okay, so hello everyone, and as Ayushi just mentioned, I completed my 3rd year recently, and now I'm currently interning at Nvidia as a hardware intern. So, talking about SIPs, so the general timeline for SIPs for the batch graduating in 2024 would be in May to July of 2023, and for the batch graduating in 2025, it would be from May to July of 2024. So basically, it is a around 8 to 10 week program, and for that you'll be giving the interviews, and the selection process will start almost a year before the actual internship. So basically, the companies that come to our campus are from the IT, electronics, chemical, and mechanical fields, and there is a pretty high chance of getting a pre-placement offer if you perform very well in your summer internships. So that is why a lot of people try to get SIPs, and basically the electronics internship. So the electronics domain is divided into 2 parts: analog and digital. And mostly companies coming in for SIPs in our campus look for digital domain, but some companies do come for analog roles. So moving on, the timeline for preparation will be provided to you by the placement unit, and I think that is very apt and very good to follow, and it gives you sufficient time to revise through things, go through things, understand things. And I would say don't focus on theory much. Try to solve questions as much as possible, because without solving questions you wouldn't know how how good you are grasping the theory. You wouldn't know if you're able to solve it or not, because the thing is that during the selection process the tests are timed, so you need to be fast and quick with solving questions. And even during the interviews, so I'd suggest that try to solve as many questions as possible. It will help you develop your logic. And so some topics that are important for analog are the basics of ES. It is the must for analog, as you must know. Then you might have studied microelectronics, control systems as well. And the RLC circuits are covered in ES basics. So basically, companies coming in for analog do look for good knowledge in RLC circuits. And op-amps you'll study in your third year, but you'll need to know the basics of op-amps for analog roles. So I'd encourage all of you, if you're looking for an analog role, please do study op-amps on your own. It will be very helpful. And some topics that are important for digital domain are DD. Static timing diagram is very important. Uh, Verilog coding, the basics of Verilog coding and basics of C programming and all is also very important. And some basics of MUPI and Compact is also necessary for digital domain. So coming to my experience from the selection process of Nvidia, the CGPA cutoff was 8 and above, but it varies every year. It is not fixed at all. There were two stages. There was one written test and one technical interview. So the written test was 50 minutes long, consisting of 19 questions, and the format was mostly MCQ and fill in the blank types. So they mostly ask questions from the digital domain and basically digital design, some concepts of compact, and questions from C programming. So you need to know programming because Nvidia especially asks programming related questions every year. And the technical interview was of 45 minutes long. There was only one interview, and they had asked me 4 to 5 questions. Few questions were on logic based questions, where there some of them were logic based. 2-3 questions were based on digital design, and one was from Moore and Mealy machines also. And one question was of programming type, wherein they had asked me time complexity related questions. So I'll hand it over to Stuti now.
Hi, I'm Stuti, and I'm interning at TI this summer. I will be talking about TI and some other companies which came to campus and how to prepare for digital and analog roles. So I'll present my screen. Is it visible?
Yes, it's visible.
Okay. So the CGPA cutoff for TI was 7. And here, CGPA does not play an important role. After the cutoff, they do not look at your CGPA. So just yeah. Then first there was a written test, and then there was a technical interview. There was supposed to be an HR round, but that did not happen. So in the written test, there were 3 sections. One was analog, digital, and then the third was aptitude. So if you want to sit for digital profile, you can only give digital. Aptitude is compulsory. And if you want to sit for just analog, you can give just analog. And if you want to see which one you're good at, you could give both, and they'll take the best performance. Each section had 20 MCQ questions. Be a little quick in the aptitude section because the time limit given is less and the number of questions are the same. So that's a pretty lengthy section. Then coming to technical interviews, the panelists were very sweet. So if I was getting stuck, they were helping. So don't worry. If you don't know if you don't know the final answer, it's okay. Just tell them your approach. And whenever you're solving a question, just don't keep solving it separately and then give them the final answer. always tell your process, the way you're thinking and everything. If your process is wrong, they'll help you. So that way it's beneficial for you. So mine started with introduction. I had to introduce myself and the projects I had done. I did not have many projects. I had just the DD project which I had done for the course. Then I had the MUP project, and I had my PS1 project and a project I had done for an online course. So I spoke about my DD project, and it was based on pattern matching. So the first question they asked me was on pattern matching itself. So I used FSM for that. You would have studied in DD. And I was asked how to do that using shift registers. And yeah. And then very basic questions they asked on universal gates and how to make different gates using universal gates. Then we asked questions on propagation delays. Static timing analysis is very important. You will learn it in ADVD, but yeah, you'll have to study this part on your own. You can take your seniors' notes or you can study it online. Don't skip STA, static timing analysis is very important. Then on flip-flops and duty cycle, those are also standard questions. Counters, frequency buy-in, dividers, and everything. And yeah, also glitches. For the written test, there was this important topic called glitches. Later, also, when you go for testing and validation, when your profiles are that, you will have to work with glitches, consider them. So they usually ask questions on glitches. So you'll have to study that too. A total of 4-5 questions were asked. And yeah, the panelists were very sweet. For Qualcomm, the CGPA cutoff was 7.5. There were 2 rounds, written test and interview. In the written test, there were 3 sections again, 3 sections. And first one was programming. They asked a question on Java programming. The second was digital and third was aptitude. The digital questions were similar to what I had told. The topics were similar to what I had discussed. Yeah. Western Digital did not have a written round. Here, your resume makes a difference. So make sure you have made your resume very nicely. So they shortlist based on your resume, and then you'll have a technical plus HR interview. You'll have just one interview. In that, they'll ask questions on your resume and on the projects you mentioned in your resume, and a few questions on DD and MUP, and general HR questions, future plans and stuff. Now, preparation for digital, Morris Mano is the best book. If you have solved and you've understood the concepts in it, you're pretty much done. Then there are good questions and explanations on Geeks for Geeks. You could look at that. Then static timing analysis, you could refer to the site or ask a senior for their ADVD notes. Then, yeah, these are the remaining topics. Also, Verilog, Maneser's notes, or even Morris Mano has some basics of Verilog. That's sufficient. Yeah, also study glitches. This is the preparation material for analog. So, yeah, you'll have to study ES. MUE, Champion Sir's YouTube playlist is there, and the textbook is good. Also, analog electronics of 3rd year, in that operational amplifiers. So TI's analog section mostly had questions from operational amplifiers. So you will have to study that on your own. It's a very important topic for analog. Yeah, now I'll pass it on to Ashlesha.
Hi everyone. Okay, so I hope my screen's visible. Right. I'll be speaking about the PU material. So the material that will be shared by PU with you will have 2 sections, digital and analog. Now digital has, I guess, like 4 PDFs. One is on aptitude questions, one has questions based on interviews, like it's a set of 52 questions, and it covers nearly all topics, like questions which will be asked in the written round as well as the interviews. And then there are two more PDFs on just questions on op-amps or like STA, all the topics which were mentioned by Mansi and Stuti. So ensure that you solve each and every question in that. Like once you're done solving Morris Mano, the next step is to check that if you can solve all of these questions in the PDFs. So go through them properly. There are also comprehension and pattern type questions in the paper. So what they do is like they give you this one big passage, and then they include like 3 or 4 characters in it, like XYZ or like some kind of animals. And then the following questions are based on like, the pattern associated between them. So you need to ensure that, you get at least like you, if you mess up one, then all the other 4 parts will go wrong. So read it properly. This will come in the aptitude section, but like TI focuses on these questions like nearly in all of their papers. So go through them, like, read up about it on the net or like other resources. Right now for logical reasoning, this is a very cool YouTube playlist that I came across. So it has like these um, riddles which have been solved through animations. So in during your interviews as well as in the written round, there are at least 2 or 3 questions which will be based on these famous riddles. And in this YouTube playlist, they've solved all of these riddles, and like, they'll just change the characters' names again. And but if you just get the basic gist of the entire riddle, it'll be like you'll be good to go. Now I'll be speaking about the interview. So the first thing is just going thoroughly through the SIP Chronicles. It's a very good mention of how the previous interviews have been. So just go through them properly. Everyone has a different experience, and it's always good to know about each one's experience. So do that. The next is about your interests, knowledge about the company and that area of work. So in the interview, they'll always ask you about, why you're looking forward to work in Nvidia, or why you're looking forward to work in TI. So you should have a basic idea about what that company is currently working on. And then you can say that, I've worked on these lines or something, and I hope to work on that. So by this, they realize that, that you're genuinely interested, and then, you'll work towards the vision of the company. Next is about tell them about what you want to be asked. So now they have your resume during your interview, right? And like on the basis of that, they'll ask you questions. Now firstly, you need to be very thorough with your resume. You can't like bullshit in your resume, because in case they end up asking you on any such project or any such point on which you haven't worked properly, it really won't look good. So ensure that like you know what's there in your resume. And like my strong point was DD. I wasn't very good at perhaps like programming or something. So I ensure that I spoke about DD when they asked me to introduce myself, and then like my interview followed on those questions. And this is something like it's all up to you that how you want your interview to go. So emphasize on those points on which you want to be asked. Right. Next is explain the logic for one of the written down questions. So they'll ask you to explain the logic of one of the questions which comes in the written down. They might just change few parameters, but like even after the paper, if you haven't been able to solve all the questions properly, just go through your rough work once, so that you know that you'll be able to justify your reasoning to that question. Next, you'll be asked on like frequency division, input gate 2:1 mux questions. They'll ask you to extrapolate the logic. Like they'll ask you a question on say make a 3-input NAND gate using a 2-input NAND gate. Then they'll ask you to do the same for a 4-input NAND gate, and then they'll ask you to apply the same logic to an N-input NAND gate. Again, they'll put like few variations in it. So one tip, like make a list of all of these combinations which are possible, like the different gates that are there, the different smaller 2-input gates which you can use to make these N-input gates. So have them all written down, and they make it like they start with basic questions and then they build up on it. All right. Next is logical reasoning, C programming, algo. and Verilog. Okay, you need to go through Verilog very well. So there are, I guess, Professor Mane's notes. I think we put their link in the preparation material. So just go through them. Like they might ask you to write the Verilog code for one of the modules, or even for C programming, they won't ask you to like code it properly, but they'll ask you to come up with an algo to just like, the sorting algo. But what is the most efficient way of doing it? So that's what they'll ask you on. So don't need to be very good at coding, but just have the famous algos, like go through them once so that you're able to answer them. Lastly, they'll ask you about future plans, like do you plan to do MS or do you plan to work? So you need to be diplomatic. Like if you actually plan to go for MS, you can just say that I'm in my third year and I haven't planned anything right now. Like just go around it. Like don't say that you want to go for MS, because then they might not like consider you. So you need to be diplomatic while you're answering this question. um Right. The last point is about the general tips. Okay. So firstly, you need to ensure you have good net, because you have a lot going on during the interview. So ensure that you're sitting at the right place. You have a backup net connection so that if anything goes wrong, you're able to connect within a few seconds and get back to the interview. Think out loud. Now, this is the most important point which has been told to us by seniors, and I guess it worked for all of us. So when they pose a question to you can't just like solve it and then once you get the final answer tell them, okay, this is the answer that I've gotten. You need to like speak out each and every step you're doing. Like even if you're making a mistake, it's fine, but you need to speak out each and every single step. I cannot emphasize more on this. It's very important, because that's how the interviewer knows how what's your approach for the question. He or she gets to know how you're thinking, and that's what they are looking out for, right? They want to see like how efficiently you come up with the answer, or what is like, what's your perspective towards each and every algo, or like, the aptitude question that's given to you. And they might also give you all hints. So take those hints and then build up on it, all right? But speak out loud. Like this is very important. Yeah. Now practice previous year company specific questions. You'll get them again in the PU doc. Like PU also shares a lot of material. Like once you qualify after the written round, they'll give you another PDF. They'll get you in touch with the seniors who've qualified for the following rounds. So speak to all of them. Again, practice each and every question. It's nearly the same set of questions they keep on asking. So go through that. Read about the company. I've mentioned this. And yeah, lastly, if not SIP, then what? So, I mean, right now, like for electronics, there aren't a lot of companies that come. So it might be a bit demotivating. So I feel like whilst you're preparing for SIP, in case like, by the end of August, you should start looking for research internships, because this really helps. Like you need to have something planned for your summer, and research internships also have great value on your resume. So start looking for that. Start with the cold mailing. Speak to the relevant seniors who can help you in getting them. Do SOPs in formal projects. LORs are also very important. um, Read up about the other core electronic companies that come. Even on LinkedIn, there are so many bits in startups, bits in electronic companies out there. You can always like, ping them and like ask them if they're looking for interns. And, these people are really helpful. They come up and they easily help you out. So just like, have these things in mind, like once the SIP season gets over. Right. And yeah, so that's about it from the three of us. Like this is what we mentioned in our previous talk also. So I guess we've covered everything. Like we're done with half an hour. Now we'd like to like go ahead to the FAQs which were put up in the Google form. So we'll take them up. And once that is done, we have few like, questions planned for y'all. So we'll solve few questions, just like a starter for y'all. For your SIP process. So, guys, Stuti, Mansi, do you all want to begin with the FAQs?
Yeah, I think I'll take the first one.
Yeah.
Okay, so is CGPA important only to clear the cutoff, or does it actually matter a lot during selections and companies like TI? So, as I had mentioned, once you clear the cutoff, they don't look at your CGPA. It's solely based on your technical rounds, your written test, and your technical interview. And some companies consider the projects you've done. So, after the cutoff, no, your CGPA does not really matter. what all skills should we know other than the training, the things taught in our course curriculum? So, for digital profile, you'll need to know static timing analysis. I suppose you all were not taught Verilog. We were taught a little bit of Verilog, so you'll have to study Verilog too. Apart from this, glitches. Yeah, I think for digital only so much, and for analog operational amplifiers.
Okay,
Yeah.
so I'll take the second question. I'm a dualite. I haven't studied electronics till now. So how do I decide if I want to go in for an electronics or ITSIP? So for this, I think that you have ample time. You have 1 year to figure that out. And I think the next semester you'll have important courses like digital design and all. And you can get a clarity after doing this course that if you like electronics or not. And meanwhile, you can try coding also. So to see where your interest lies. So that would be my tip to get a clarity. So finish off your 3-1 courses and see if you like the courses, and meanwhile do some coding also, so you get to know as if you like or not, and does it have scope if I'm not interested in doing MS. So if you want to pursue a SIP in electronics, people generally hope for a PPO to get placed in an electronics company. So I don't think masters is related for in this matter. And taking up the third question, what work do we need to do exactly as a hardware intern? So I'll answer this for Nvidia. So in Nvidia, we divided into CPU and GPU teams, and these teams have in turn different units. So there is a architecture unit, there is a validation unit, there is a design unit, there is a physical design unit, and so on. And I think that goes with every company. They all of the companies would have this units, and according to the project requirements or your resume, they allot you a project and you work on that project. And apart from Nvidia and Texas Instruments, which companies offer summer internships? So as mentioned on the slides, we had Qualcomm, we had Western Digital, we even had Silicon Labs come in, but it came a little late. And yeah, so there are a couple of companies that do come. We had Google hardware also, not in our year. Our seniors had it. And do these companies see what projects we have done under professors, and is it very important for securing SIP? So if you mention the projects that you've done in your resume, and so they might ask you about what your work was, so you should be thorough with what you did. And projects are very important in my opinion, so I think you should mention it and be thorough with what work did you do. And it's not necessary to secure a SIP. There is always the option of placements or PS2 or offline internships. So not getting an SIP is not the end of the world. You can always have other options. I'll move on to Ashlesha. She'll answer the last two.
Okay, so my question is, how much emphasis should we give to academic CG compared to personal projects, skill development? So I'd say, look, guys, CG is important. I mean, it's the threshold for y'all to qualify uh, to a particular company. And I've heard like few companies do focus on high CG. On the contrary, lately the trend has been that people are going for people with lower CGs because they think that, these people won't go for masters. So every year, this is an oscillating trend. I'm not quite sure about it, but having a CG above 8 is definitely like the safe way to go about it. Like even for placements, 8 plus CG is always safe. Nvidia initially had a cutoff of 8.5. It was reduced to 8 this year, maybe because of COVID. I'm not sure. So, right, but like have a CG above 8. But as compared to having personal projects versus skill development, now I personally feel like this is very important. like, working for particular clubs or departments, or, doing other extracurricular activities. It just helps you grow as a person. It gives you confidence. And later, like at the beginning of your interview, when you have to introduce yourself, you should have things to speak about other than acads and all. What these companies are looking for are people, who will be a better team player than an individual player. So if you're someone who's very good at speaking, who dwells in well along with the other team members, then it invariantly adds to the productivity of the work that you're doing. So I feel like, it's important to invest a little bit into your skills, into your personal projects, and doing other things also. And it also introduces, like, it prepares you to work in a team in the corporate sector. So I'd say, yeah, definitely focus on that as well. Do companies visit for analog profile or just digital domain? So I think we've answered that. It's not just digital domain, like TI specifically comes for analog. Right now, the work that I'm doing at Nvidia is kind of like analog only. I'm working on CMOS, VLSI, on STA. So all of that comes in, like, the analog part, physical design layout, as well as the company Silicon Labs. Now that was focusing on antenna design. So if you're an ECE student, you'll have the course EFME next year. So, like their entire paper, the written round was based on it. So yeah, it's not just analog digital. There's also Western digital, which focuses more on coding, and like it's more like a software role also integrated with just like like the chip part, but primarily focusing on the coding part of it. So yeah, right. So I guess we've answered nearly all the questions that had come to us. Do you guys have any other questions? Like, if you all want, you can put them in the chat box or like raise your hand. Else we'll move to the questions. Okay, cool, fine. So could you all, like, I just like to know that, are you guys interested in like solving questions with us? I mean, we put all the links in the doc and all, but like, do you all want us to solve questions? If yes, like just raise your hand so that, we could proceed with that. Okay. Okay, I just have like two girls raising their hands. Anyone else? Okay, we have three here. Mansi, Stuti, we'll solve questions, no? Or what should we do?
Yeah, I think we can solve one question and see if they are comfortable with it or not.
Okay, cool, fine. So I'll just present my screen again. Right. Okay, so guys, I'm beginning with the STA question. So static timing analysis, as mentioned by Stuti, is a very important topic. You'll find a question on it in like every company's written round. So it's something you should focus on. So we mentioned the website, the VLSI expert website. That's a very nice, I guess it's a blog written by someone, and he mentions all these concepts in a very beautiful way. He's put up like nice examples, and like sometimes companies just pick up these questions, change the parameter values, and they'll give it to you all in the written round. So just go through it like properly. Okay, so right now we'll be doing right. So I'm going through the concept of setup and hold time. So as you guys can see, this is our clock signal, and this is our D signal. So this is the output waveform. So now setup time, as defined, is the amount of time the data at the synchronous input must be stable before the active edge of the clock. So this is the active edge of the clock, and the amount of time the data should be stable before before like the clock changes to 1 is our setup time, and our hold time is the amount of time the data should be stable after the active edge of the clock. So I think like it's pretty much straightforward here that this is our setup time and this is our hold time. Okay, so now this is a very generic question which can be asked. So they'll give you a set of flip-flops and they'll just like add few components here. They'll put a buffer here. They'll have few buffers put in the clock path also. So we have flip-flop 1 here, flip-flop 2 here. This is an inverter and this is a buffer put here. Now the questions which will be asked, that they'll ask you for the hold violations. So they'll ask you that, if a hold violation is being created or not. Similarly, they'll ask you to find if a setup violation is being created or not. And lastly, find the maximum clock frequency. So mostly they'll ask you to find the clock frequency, but we'll begin with the hold violation. Right. Now for hold analysis, what we need to do is we need to find the difference between the time in the propagation delay of the data path and subtract it with the time propagation in the clock path. And the difference of these two should be greater than 0. Now we have the minimum delay along the data path and the maximum delay along the clock path. Just look at this equation now, right? We want this, like we're looking for that case in which the case which will give us the least difference. And that you'll get by evaluating the difference between the minimum delay along the data path and the maximum delay along the clock path. Guys, do you all have like any questions? I hope I'm clear with this concept.
It would be great if you could be a little more interactive, so that we also know that if you're understanding or not. Did you understand what she just explained?
Okay, cool. Okay, this is a
You
dead
did it.
we have during our lectures. Yeah, fine. Okay, guys, so this is like D, right? This is the time when the D input is stable. It's stable for this duration, right? And setup time is the time, like the amount of time for which the data is stable before the active edge of the clock signal. And likewise, hold time is the amount of time the data is stable, like this is stable after the active edge of the clock signal. So now the question is based on this concept only. We need to find the minimum delay along the data path. So I've drawn a line which shows us like this is our data path. So this is our clock path and data path is via the flip-flops, like going from one D to the other D. So now to calculate this minimum delay, we need to do the summation of all the minimum parameters along our path. Now for the data path, I begin from my clock, like my path first begins with this clock, then it evaluates the waveform for the Q output. So we need to consider the T clock Q. Then we need to consider the minimum time for this path of the before the buffer, then the duration for this buffer, then for this path line, and finally we come to this flip-flop. So now to calculate that, we have T minimum, that's 1 nanosecond, T clock Q minimum, which is 9 nanoseconds. Now minimum for this 1, 6, 1. So the summation of this is giving us 18 nanoseconds. It's pretty simple. We just have to take the minimum value along the data path. All right. Next, we go on to calculate the maximum delay along the clock path. Now we just do the summation of the maximum parameters. So that'll be 3 plus 9 plus 3 plus 2. All right. So when we are considering maximum delay along the clock path, for this clock path, we need to consider the hold and the setup parameters. And now since we're doing the maximum delay along the clock path, when we're considering the clock edge signal, we need to see for how much time the data is stable after the clock edge signal, because we're considering the maximum delay that can be incurred during this path. So for that, we need to add the hold time. So this gives us 17 nanoseconds. So we got TD as 18 nanoseconds and we got T clock as 17 nanoseconds. The difference of it is 1 nanoseconds, which is greater than 0. Hence, we don't have any hold violation. Okay. Yeah. So similarly for the setup analysis, now we need to find the difference between T clock minus TD. all right, and this should be greater than 0. Now for this, we'll find the maximum delay along the data path and minimum delay along the clock path. We're evaluating it for the case which will give us the minimum difference between the paths, right? And this will this will come up for only these two cases. So for that same procedure, for TD, we're finding the maximum delay. So we consider the maximum parameters, which is 2 plus 11, 2 plus 11 plus 2 plus 9 plus 2. So that's giving us 26 nanoseconds. And next one, okay, yeah. So to calculate the minimum delay along the clock path, now we need to look into the minimum parameters, but when we're looking at the clock edge signal, we need to subtract the setup time. Now this is because if you look at this diagram, when you're evaluating the whole time, it is at the same clock signal. But when you're considering the setup time, it's actually at the next active clock edge signal. Like if you consider this is going to be our, one second, I'll just draw. This is our waveform. Yeah, right. So when we're considering the whole time for the maximum delay, this is the first edge that you'll incur, that you'll come across. So at that time, you'll be taking into account for this edge the whole time. But for the whole time, for the setup time, you have to look into the next clock edge, because this is something which comes later on. So for that, you'll have to subtract it. I hope I'm clear with that. Like this is a tricky concept. So just remember that when you're considering the setup time, it's always at the next active edge clock signal. So that's why first you need to consider the clock period. So this will be mentioned in the question. T clock will be equal to 15 plus the minimum parameter, which is 2 nanoseconds, then 5 nanoseconds, then 2 nanoseconds. And then you have to subtract the 4 nanoseconds. This is, like I like to just mention once again, this is because we consider the setup time at the next clock signal, and whole time is considered for the same clock signal. So that's why we have to subtract 4 nanoseconds, and that's how we get T clock as 20 nanoseconds. So we got TD as 26 nanoseconds and we got T clock as 20 nanoseconds. So 20 minus 6, 26 gives us minus 6 nanoseconds, which is less than 0. Hence, we have a setup violation. So whenever we incur violations, we have to add few components. Like we might have to add some buffer out here and see to it that, our T clock is more than that. So perhaps if I add a buffer here with a duration of 7 nanoseconds as the minimum delay path, then this sum would come to 27 nanoseconds. And then when I do the difference, it'll be greater than 0. So that's how I would have solved my setup violation. So they might ask you questions on this in the interview. So just go through the material properly. It's an easy concept. And lastly, the question would be that finding the maximum clock frequency. Now, to calculate the maximum clock frequency, it's the reciprocal of the minimum clock period. And we get the minimum clock period by evaluating this expression, which is the maximum data path delay minus the minimum clock path delay plus the setup time. So now in these previous two questions, we've calculated each of these parameters. So minimum clock period, okay, let me just change its font color. Yeah. Okay, so minimum clock period, which we got as 26 nanoseconds. So a maximum delay along the data path was 26 nanoseconds. Minimum delay along the clock path was 20 nanoseconds. So that is 26. 1 second, sorry. Yeah, that's 26 minus 20. And we need to add the setup time, which is plus 4. So that's how we get 10 nanoseconds. And the reciprocal of which will give us the clock frequency to be 100 megahertz. Okay. Yeah, so this was one big question with few subparts, but most likely they'll ask you the clock frequency. So you should, you need to solve all of these parts in order to get the clock frequency. Okay, so that's about it. Guys, any questions on this? If y'all didn't get any concept, like let me know. I'll just go through it once again. Okay, cool. Should we move to the next question? Like you guys could just put a yes in the chat box so that we know we should proceed with the next question. Mansi, you want to go ahead?
Yeah. So, guys, are you able to understand what she just solved, or do you want us to solve more questions like this so that you get a basic idea of how questions will be in the interviews as well as the written test? Because this type of questions would be there, like mostly be there.
Yeah,
So,
STA, you will get a question for sure. And like these are not very difficult concepts, but we just thought like that's what we were told, that you guys are just struggling with starting the prep. So we thought like if we start with some basic questions, you'll get the confidence to solve more of these. So yeah.
it would be great if you just could say yes or no.
Yeah, it's just like such like few of us guys, like you can just start speaking up. Okay, at least tell us if we should go ahead with the next question or not.
You can just raise your hand if you're not okay with typing.
Okay.
We've got a
Yeah,
yes.
fine. I'll present Ashlesha.
Yeah, cool.
Also, these slides will be made available after the session as well. So if you want to go back and refer, it will be there.
Yeah, so another popular question is a question on Moore and Mealy machines. You will most probably get a question on this for sure. So, as you might know that Mealy machine is a machine whose output values are determined both by the current and state and the current inputs. And whereas the Moore machine, the output values are just determined by the current state. So, I just have a quick question for you guys. Which FSM do you think would have more number of states, if any? If you could just type in the chat. Okay. So, see, basically, in milling machine, as you can see, the output is mentioned on the arrows, whereas in the Moore machine, the output is mentioned within the state itself. So, generally, there might be an extra state required in the Moore machine, and milling machine would require a lesser number of states than the Moore machine. So, you need to be careful regarding that. So, I was asked a question on sequence detecting in my interview. So, I thought of including a question on detecting a sequence here. So, the question is we need to design a Moore and Mealy machine. So, to detect 3 or more consecutive ones in a string. Okay. So, the the thing and the approach to start off this question is to prepare a state diagram. Okay, so what I did was that I created the first state and then to check what the outputs will be for the respective inputs, right? So if the input is 0, the output will be 0 and it will again go back to the first state, right? Because we are detecting a sequence of ones, right? And if the input is 1, it will move from the first state to the second state, right? And so from the second state, again, there might be two possibilities. So if the input is 0, we are going back to the first step because we need a sequence of 3 or more consecutive ones. And if the input is 1, we'll go to the next state. And in the next state, we'll check if the input is 1, we'll output 1 and loop back to the same state, or else if it is 0, we'll go back again to the first state. So in this, it is very important that to check the cases for each and every input and output pair. You can make more number of states. That is not an issue. You can always reduce it using the reduction method. But you need to be clear with the state diagram that you make. Otherwise, your question won't be right. So this is a notation that I have used for the states. So this is a Mealy machine and there are 3 states here. As you can see, the output is stated on the arrow itself. This is input/output mentioned. So I made a state table for this Mealy machine. So you can see that I'll need 2 bits for representing the states. So I'll need Q1, Q0 bit for representing the state. There's a typo here. It should be present state. So the present state and the input and the output depends on these 3 things. So using K maps, you can get the equations of Q1, Q0 of the next state as well as the output. So you can see here that the input 110 and 111 will be treated as don't care here, and you may be asked to implement this state table using a D flip-flop, JK flip-flop or T flip-flop. It can be anything. So here I've implemented it using a D flip-flop. These are the equations that I got using the table and the K maps, and this is how it was implemented. Okay, so you may be asked questions on how many flip flops might be needed or how many AND gates will be required in the realization and things like that. So you need to know your basics. So that was the Mealy machine part. Moving on to the Moore machine part. So you can again start off with the basics. So you can start off with the initial state. So if the input is 0, it will loop back to itself. If the input is 1, it will go on to the next state. And here you can see that the output is mentioned within the state itself. So you need to be cautious about this. So again, there will be 2 cases and the same thing will be repeated here. But now, as you can see, when the third time of 1 is there, we need the output to be 1, detecting a sequence of 3 ones, right? But here the output is 0. That is why we need one additional state to represent the output 1 here. So the thing that I mentioned about extra states being in a Moore machine, that is clearly depicted here, right? You need 4 states here, whereas you just needed 3 states in the Mealy machine. So, but you can use as many extra states as you want. You can always reduce it if you're getting confused. So you can use more states. There's no compulsion on that. So again, the notations that I use, I need 2 bits again because there are 4 states here. And this time, what I've done is the first state, that is A, I have represented using a JK flip-flop, and the second state, B, that I have represented using a D flip-flop. Okay, you might be asked things like that, so be prepared for this. So you need to know the excitation table for a JK flip-flop. The excitation table for a D flip-flop is pretty easy, right? So according to the excitation table, I've come up with the final equation like this. And this is the final diagram using a D and JK flip-flops for the Moore machine implementation. So yeah, so that's all about Moore and Mealy machines. I'd like to stress about the importance of this. This is very important. You should be thorough with this. And regarding the excitation equations for JK, T flip-flop, D flip-flop, you might be asked a lot of questions about, let's say they'll ask you questions on how many AND gates, NOR gates, NOT gates use. So your concept should be clear. So did you guys get this question? I mean, during my interview, I got a similar question, and they cross questioned me for a long time on that. So that's why I feel that this is very important to know. Any questions, guys? Stuti, do you want to?
Do you all want us to solve another question? This is also an important question. It's frequently asked. Um, yeah, it was there for my written test as well as interview. If you want me to solve it, say yes. It's based on frequency division.
Also, you'll get all these questions in the preparation material. So provided by PU. So you can solve it from there also. But we thought it would be great that if we could solve it with you, so you'd know how to approach a question. Yeah, Stuti, continue.
Should I solve?
Guys, even one person, if you raise your hand, will go ahead with it. So if you are interested, then just put up your hand. Next 10 seconds or so. Okay, great.
Okay.
Stuti, I think you can solve it. There are a few interested people.
Okay. Is this visible? Is the Jamboard visible?
Yes, it is.
Okay. This is a frequently asked question where you're given a clock signal or a reference signal, and you're expected to um, generate another signal. So in this question, the top signal in black is the reference signal or the given signal, and you're expected to generate the signal which is there in black again, but the bottom signal, this one. So basically, here you're seeing that the reference signal has a higher frequency and the generated signal has a lower frequency, greater time period. So you're basically dividing the frequency by some amount. What do you think this has been divided by? What do you think the value of n is? You get this from this. Okay, so this is a divide by 7 signal because the time period of the signal is 7 times the time period of the first signal, the given signal. So how do you generate this? Any counter will generate a divide by n signal, but the important part over here is the duty cycle. For most applications, we prefer a 50% duty cycle. But again, some devices might need 33% duty cycle or different duty cycles. So it's important to to generate a wave with a given duty cycle. So here, we could use any counters, asynchronous, synchronous, ring counters. You guys would have learned it in DD. So I'm going to solve it in two ways. One is using modern counter, and in another way is ring counter, but I'll do that for another value of n, so you guys get practice. So first, let's start here. I have a mod 7 counter. So a mod 7 counter will have 7 states, and it will require 3 flip-flops, q3, q2, q1, and q0, and these would be its states. Okay. So now if you see this Q2, you would see that it's low for 4 clock cycles and high for 3 clock cycles. As over here, this is Q2 in blue. So I've marked the rising edge of the clock in green and the falling edge of the clock in red. So you can count and see that it has 4 low cycles and 3 high cycles. So how much should the duty cycle be? It would be 3 by 7. So that's 42.86%. Now in the question, they've asked you to generate a signal with a 50% duty cycle. So you'll need to make some changes here. What would you do? Here, this is low for 4, high for 3. You would want it to be low for 3.5 and high for 3.5. So you would need another signal which is shifted by half a cycle, and then you can just OR these two signals to get a 50% duty cycle, right? So Q2 is in blue. Q2 star is Q2 shifted by half a cycle, and the one in black is the required signal, which is Q2 or Q2 star. Okay. To get that, we would use a first mod 7 counter. Then take Q2 from it. So what shifts the signal by just half a cycle? On the negative edge here, see. It would be a flip-flop, a negative edge triggered flip-flop. A positive edge triggered flip-flop will delay it by one whole cycle, and a negative edge trigger will delay it by half a cycle. So here we need it to be half a cycle because we need 3.5 high, 3.5 low, and 3.5 high. Here it's 4 high, 3 low. So you need it to be delayed by just half a cycle. So I will use a negative edge triggered D flip flop. So here you get Q2 star. Now we just need to OR these two. That's all. This is the output Y. This is Y. Okay, now suppose you want the duty cycle to be 57.14%. What would you do? In that case, it would be high for 4 clock cycles and low for 3 clock cycles. It's simple. You would, instead of using a negative edge triggered flip-flop here, you would just use a positive edge triggered flip-flop. So this would be shifted by one whole cycle, and then you would OR those two. Yeah. Now, same frequency division problem, but we are using a ring counter. So this ring counter has 5 flip-flops. What do you think the N value should be in this case? It would be 5. So one of these would have a reset state of 1, and the remaining would have a reset state of 0. So let's assume that, yeah, this is Q1, Q2, Q3, Q4, and Q5. Okay. So, and then it would circle back. So this is it counts five states, between 5 states. And the signals would be like this. This is Q1. It will be 1 first, right? One clock cycle. Oops. Yeah, it would be high for just 1 clock cycle and then low for 4 clock cycles. And then again high for 1 clock cycle, low for 4 clock cycles. Similarly, Similarly, Q2 would be high for 1 clock cycle, low for 4 clock cycles, high for 1 clock cycle. Yeah. Similarly, Q3, it will go on. Now we want to generate a 50% duty cycle waveform. If you see any one of Q1, Q2, Q3 is just 20% duty cycle because it's high for one cycle and low for 4 cycles. So 1/5, you get 20% duty cycle. If you want 50% duty cycle, you'll use the same logic as you used over here. You could just OR Q1 and Q2. So if you OR Q1 and Q2, you would get 40% duty cycle, right? Now from 40% duty cycle, you want to make it, you need to make it 50%. So you will need Q2 to be shifted by half a cycle, right? So let's call that Q2 star. So Q2 star would be shifted by half a clock cycle. It would be like this, right? Now, if you OR all three of these, you would get a 50% duty cycle waveform. Yeah. That's all. You could use this logic for any value of n. They would tell you to either use ring counters or synchronous, asynchronous counters, modern counters. They would tell you, or they wouldn't give anything, and you could select either and solve it this way. Yeah, that's all. Any doubts? So in this case, this would just be Q1, Q2. Here you'll need a negative edge triggered D flip flop, and you just OR all of these. Oh, this is so messy. Yeah, this would be Y. So the frequency of this of Y is 1/5 the frequency of the reference signal. This is the reference signal, and the duty cycle is 50%. You can generate different duty cycles using the same logic. Any doubts? You could ask me if you have any doubts. Oh, my bad. This would be Q2. If you have no doubts, I think we could conclude. Ayushi?
Yeah. Um, Okay, so we'll wrap up now. Thanks a lot, Stuti, Ashlesha, Mansi, for taking the time to have this session. I'm sure it was very helpful to everyone who attended. The slides and the recording will be put up on our YouTube channel, so watch out for that if you want to revise anything. Um, Other than that, thanks for coming, guys. Have
I
a good
had a
night.
doubt.
Yeah.
Well, where is the CGPA like considered? Like, is it your for a 25 dual light? Is it the 3-1 CGPA that's considered or till 3-2?
3-1.
3-2.
3-2, yeah.
Yeah, like it depends on when the companies come. Like for
No,
us,
she
because
is dual-eyed, I think.
no, but like since it was COVID for us, that's why our CGPA till 2-2 got like included, right? Like if companies start coming early and like if at all
Yeah,
your
so it depends if the CGPA isn't released of your 3-2, then till 3-1.
yeah, PS, sorry, the PS
Yes.
grade. Yeah, that's what matters. Yeah, 3-2 will be considered. Right, for you it will be 3-2. Like for us single degree people, the question is whether they'll take into account a PS grade or not. So if the PS grade comes out early, then like it's good. And like,
Yeah, for us it was considered.
Okay. Thank you.
Okay, are there any other questions? Cool. Thanks, everyone. Have a good night.